The topic is functional human anatomy and physiology in physical education and sports. So help me welcome Mr. Tank to take us through. Thank you.
Yeah, thank you. Thank you very much, John. I'm trying to, there we are. There we are. Sorry. Yeah, so ladies and gentlemen, I'm humbled once more to be presenting to you today. First of all, that's my profile. I'm a senior lecturer at the Department of Physical Education and Sports at the Faculty of Education, University of Nairobi. I'm also on the sporting side. I'm a world rugby trainer, former Kenya Simba's rugby coach from 2007 to 2012, Kenya Shujaa rugby coach 1998-2000. Also coached our local club, currently one of the top clubs in Kenya, ACB, from 2002 to 2010. I'm currently a member of the National Olympic Committee of Kenya Institute Commission. So that's really basically who I am. So straight away we move to the course objectives. Now, we will first of all start by just looking at the importance of studying anatomy and physiology for human movement. What relevance does it have to our sports? And it's also important to know the structural levels of organization of the human body, identifying and describing body systems and their structure and functions, identifying body structures, describing their relationship using appropriate anatomical terms, identifying body issues and describing their structure and functions, and describing the structure types and functions of joints. Expected learning outcomes at the end of the course, and not really this particular course, but at the end of any course that you do in functional human anatomy and physiology, you ought to be able to explain the terms and concept of anatomy and physiology and their application to skill acquisition in sports, apply those principles and their impact on acquisition of skills in sports, differentiate the different types of energy systems. That to me is very important. And we'll come to that chapter where we are differentiating the types of energy systems in the human body and how they contribute to effective and efficient movement in sports. And then at the end of it all, coaches ought to be able to design a coaching plan based on those principles for application of effective and efficient execution of appropriate skills in the relevant sport. I have divided the presentation into about 8 chapters. I would have liked to have shown some diagrams, but we don't have time for that. So what I've done is at the end of every chapter, I have given you a link to a presentation on YouTube, so that when we finish this presentation, I'm sure it will be available for all of you, and then you can be able to go to, yeah, so at the end of every chapter, if you go to that link, you'll be able to see whatever we are talking about. There'll be a short, maybe 15 minutes or 20 minutes, or some are even 10 minutes, just to show you visually what we are talking about. The course content, we are looking at an anatomical position during the introduction, and probably some movement patterns. But mainly we want to look at the skeletal system. I've not talked so much about the cells and their functions in the body. That is a bit basic. But we look at, first of all, the first 4 systems. And why I've chosen these 4 systems: skeletal, articular, muscular, and nervous. If you remember in biomechanics, the body is just a human machine which is operating on the basis of a lever system, where we have the rigid bar, we have a fulcrum, we have a load, we have an effort, Yeah, and if you look at it carefully, you will see that the skeletal system gives us the rigid bars, the bars. The articular system is the fulcrum. The muscular system is the effort. And the nervous system is more or less the messenger that coordinates all these movements. And then when we look at the physiological part, I have focused more on the respiratory system and the energy systems, and also tissue respiration. So I'll quickly take you through the first bit where we want to look at, okay, let me just introduce it before we go into the skeletal system. And the human body is, first of all, made up of the single unit called the cell, and then groups of cells that are grouped together to form a particular function are called tissues. Tissues performing the same functions are called organs, and then organs forming the same closely related functions translates into a system. So the body works as a whole, with each individual cell requiring food and oxygen and having to get rid of waste material. So the study of this arrangement of organs is called anatomy, where it probably deals with the structure, and now physiology deals with the functions. And I have actually brought those systems, those 6 or 7 systems together, because they're the key ones that are normally involved in human movement. But otherwise, all the systems in the body contribute to human movement. Importance of anatomy and physiology. Definitely, it is important for our coaches or any physical education practitioner to understand this machine, this body. What is its structure? What are its functions? Sorry. And then when you go to exercise and sports physiology, then you're looking at how do you use the anatomy and physiology knowledge that you have gotten to improve performance by knowing how the body functions during exercise and using the scientific principles to allow your body to train better, perform better, and recover quicker. So that's the importance of anatomy and physiology. Just taking you through fundamentals, you ought to understand these 3 body planes. We normally have the sagittal plane that divides the body vertically into right and left. That is the midsection. The body is divided into right and left. That is called the sagittal plane. The frontal plane, or sometimes known as the coronal plane, divides the body into anterior portion and posterior, front and back, or front and rear. That is the frontal plane. Then we have the transverse plane that divides the body horizontally into upper and lower portions, or superior and inferior portions. Our transverse planes produce images sometimes referred to as cross sections. So it's important to know these fundamentals that deal with basically the fundamentals of movement or movement patterns. Now, again, just a revision, and I hope that you have gone through some of these movements. Very, very simple. Whenever we bend, like for example, you bend your elbow up and down, when you narrow the angle, when the hand comes towards the face, then that is called flexion, decrease in angle. The opposite of that is extension. You have increased the angle. Dorsiflexion, the sole of your foot and toes pulled up towards your leg, meaning you are standing on your toes. That is you are standing on your heels. That is dorsiflexion. When you now stand on your toes and the heels are up, that is plantar flexion. Abduction, segment moves away from the midline. Adduction, segment moves towards the midline of the body. These are just simple anatomical terms to describe movements. We go a bit more deeper there. Ulnar deviation, the hand and wrist moves towards the little finger or ulna. Then radial deviation, the hand and wrist moves towards the thumb or radius. Circumduction, when you describe a cone, extended segment describes a cone shaped in space. That is circumduction. Remember, do not confuse it with rotation. because rotation, a segment moves about its own central axis. Supination, the palm of the hand is in anatomic position with reference to the arm, while pronation, the palm of the hand is turned or rotated away from the anatomical position. Then, of course, now you have horizontal abduction and horizontal adduction. Down there, I've given you two links that really explain these movements visually. So it is something that you can be able to look at later when you receive the presentation to understand a bit more of those movements. If there was time, I would have shown them. Now, chapter 2. This is where we want to look at, there's somebody who's still, the mic is not muted. Please, if you can mute your mic because it's interfering. I'm hearing some noise in the background. The skeletal system. Remember, this is the fundamental in the liver. This is the rigid bar. The bones give you the rigid bar in that machine. Now, I've itemized these three fundamental functions. There is support. Without the skeleton, the body would not be able to stand upright. So there is that support that gives the shape to the body. Attachment of muscles, very, very important function in terms of sports performance. Movement, the bones act as levers and we need movement to be able to perform in any sporting activity. Then there is the element of protection. There are delicate parts of the body like the brain, the spinal cord, the heart, and the lungs that need protection. And you will find that the arrangement of the bones and the way the classification of bones are, there are particular bones that are there to provide movement, and there are particular bones that are there for protection and support. There are other functions of the skeleton, like so there are other functions like a production of red blood cells and storage of mineral salts and all that. But these, to me, were the three fundamental functions that I wanted to itemize. Now, bones, cartilage and bone. Sometimes people tend not to understand really what is the difference. But remember, when a baby is born, a baby is not born with bones. A baby is born with cartilage. And then that cartilage during the human growth development slowly transforms into bones. But in the human growth development period, some of the cartilage is retained. You know, for example, in between our vertebral column, you will find some cartilage there. Most of the synovial joints that we've got in the body have got cartilage, just to give some cushioning, so that bone does not really meet with bone, but there's something there to provide some shock absorber kind of situation. So there, I'm just itemizing the difference between cartilage and bone. Now, you have 5 different classifications of bones. Long bones, which are found in the limbs, and I've itemized there the basic fundamentals of the difference. The long bones, you will find those fundamentals, the shaft that is known as diaphysis, and then epiphysis, the two expanded ends. Then you have the short bones, which are cube-shaped, strong, and consisting of a thin layer of compact bones. You have the flat bones, you have the sesamoid bone. Now, the sesamoid bone, you will find that the largest sesamoid bone is the patella, which is found at the knee joint. And the function there is very, very specialized in terms of allowing some slight degree of movement, but not so much movement to be able to retain the stability of that joint. And the knee joint, the largest joint in the body, actually has got a specialized function. That's why you will find the patella, which is the largest of the sesamoid bones at the knee. And then you have the irregular bones. I just want to draw to your attention to the aspect of flat and long. Flat bones are mainly for protection. Long bones are mainly for movement. Short bones provide some degree of stability, especially, for example, at the wrist and at the ankle. where you need some slight degree of movement, but not so much that you need to maintain some stability. So you can see that. And of course, the irregular bones mainly are there, for example, around the vertebral column and all that, where you have some also situation where it is more of protection, but you need to allow also some slight degree of movement. Now, the skeleton is basically divided into two. You have the axial skeleton and you have the appendicular skeleton. Now, you will notice that the axial is more of gearing more towards protection, but some slight degree of movement is necessary. For example, in the vertebral column, in the ribs, where sometimes in soccer you jump up and twist to head a ball, or in basketball you have to jump to go and dunk, and situations like that. So that specialized area, the vertebral column especially, allows that because there is protection of the spinal cord, but you need some degree of movement. So the axial skeleton contains, there is now what we call the skull, and then there is the vertebral column, and then there is the chest cavity where you have the sternum and you have the ribs. Then when we go to appendicular, this now is movement. We have the upper extremity that consists of the shoulder girdle, the upper arm, the lower arm, the wrist, and the hands. And then you've got the lower extremity, which is basically from the pelvic girdle to the leg bones to the ankle and to the toe bones. Now, again, it is important to understand upper extremity and lower extremity. Upper extremity is more of manipulation where you are throwing activities and all that, not so much of weight bearing, while the lower extremity is more of geared towards weight bearing and movement. So you will find that some of the bones are similar, like if you look at the humerus and you look at the femur, those two bones are similar, but structurally there are particular adaptations that are there because the femur is more geared towards weight bearing and movement, while the humerus is more for manipulation and other activities that come in throwing. So those are the things that you ought to remember when you are looking at the appendicular skeleton and you are looking at the difference between upper extremities and lower extremity. Now, the application. This bit of application, I just want to emphasize a bit more on how does this system help in sports. And I've itemized particular areas there. The shape and type of bones determine the amount of movement that is required. Remember, sports is movement, and we need to really focus on that. And different types of joints allow for different types of movement. Then exercise is also important for building strong bones when we are younger, and it is essential for maintaining that bone strength when we are older. When you stop exercising regularly, you will find that there is a certain disease called osteoporosis, whereby the bones become fragile and become weak and they are likely to break. So it is important that regular exercise is maintained so that the bone adapts by building more bone and becoming denser. Again, I've emphasized the bone act as levers and also form joints that allow muscles to pull on them and produce movement. The skeletal body upright provides a framework for muscle and tissue attachment. Endurance athletes, and I think this is where I emphasize on osteoporosis, two of the key problems associated with getting older are a gradual decline in muscle mass and a potential loss of bone density. So this missing muscle mass makes it more difficult to run, cycle, or swim powerfully. And the shrinking bones also increase the likelihood of injury and the fragility of the bones which are likely to break. So it is important that people continue to exercise, even if you have stopped competitive sport or elite or competing at elite level. The skeleton also supports the body against the pull of gravity. Remember part of like in biomechanics when we talked about projectile motion, sports, the body is most of the sporting activities are just projectiles where you're subjected to the pull of gravity. So it is important to see how you can counter this pull of gravity to be able to move in whatever direction you want to move. So the skeleton also gives that support. And we also want to maintain bone strength and all that when we stop competing, like I've already emphasized. So sport performance is highly dependent on the health and skill-related components of fitness and body composition and all that. And the skeletal system forms the fundamental of this. So I've given again 3 links there on YouTube where you can be able to go and break down what we have talked about visually. So let's move on now to chapter 3. We now come to the fulcrum, the articular system, the fulcrum in that liver system. The articular system is mainly the joints, a connection between 2 bones. The system allows motion, helps to bear the body weight, provides stability, lubricates the joints, and nourishes the cartilage via synovial fluid or synovial fluid in synovial joints. During the presentation, you'll be able to understand what we mean by that better. Here, what I want to bring out here is that there is a classification of joints. We have joints, you can classify joints structurally and functionally. When you structure the joints functionally, the first type of classification is called synarthrosis, but structurally it is a fibrous joint. And this is the type of joint that allows no movement at all. So we are talking about the joints in the brain. The brain is protected by about 8 cranial bones, and the joints they form do not allow any movement at all because it is purely for protection. There are not many fibrous joints in the body, but they are there. Then the other type of classification is what we call functionally amphiarthrosis, but structurally we are referring to cartilaginous joints. And these are the joints that allow slight degree of movement. And I've already mentioned the spinal cord, where we are having a function of protection, but also a slight degree of movement is necessary for jumping and twisting activities. And then the third one, which is the most common types of joints in the body, functionally they are called diarthrosis, but structurally they are called synovial or synovial joints. I think the classification that is most common are the structurally known classifications where we have fibrous, cartilaginous, and synovial. Now, I'm going to focus a bit more on synovial joint, and I will not want to go into the detail of the structure, but there are about 5 elements in the structure that you need to know there: the capsule and the articular cartilage and the synovial membrane and the fluid. But I want to move very quickly into the types of joints, and there are about 6. I've itemized there on that table. I won't go into the details of the description that you can read later, but I've just given you the joint and an example. A gliding joint, the fundamental example here is the scapula over the back shoulder. And that is why in weightlifting, you are able to lift weights up and down. Okay. Yeah, so the scapula for me is a very good example of a gliding joint. A condyloid joint, we are looking at the wrist joint. That is a condyloid joint. And the wrist joint is important in that it allows you to grasp, it allows you to twist, it allows you to write. And that is why the condyloid joint, and I think it could be the only one. I stand to be corrected. Maybe there are 1 or 2 other condyloid joints. that you have, because of that special function of righting and grasping. Hinge joints, very common. The elbow is an important example of a hinge joint, and of course, a hinge resembles the hinge on the door, allows movement in only one plane. A saddle joint, again, we are looking at the thumb. That is another very important, another very good example of a saddle joint, and again, the ability to hold and to grasp and to write. Okay. Pivot joint, when you nod your head, like in heading the ball in soccer, and also the rotation of the head sideways. That is because of that particular joint between the first two cervical vertebrae, atlas and axis. Again, you will find that you can be able now to go and look at especially the structure of the atlas and the structure of the axis. And the way they articulate is what allows you to perform those two particular movements around the neck, nodding and then moving the head sideways. And then, of course, the most common synovial joints are the ball and socket joints, the shoulder and the hip. And I think the key difference here is that the shoulder allows for slightly more movement, while the hip joint is a bit more rigid, again, because of those two functions of manipulation in the upper body and then more of weight bearing in the lower extremity. So that is what I would have wanted to bring out in this aspect of the articular system. I think when we come to the impact in sports, there's so much, because sports is about movement. So joints give you that, naturally giving you the ability of flexibility, strength, and then in movement, there's the lubrication of the joints to reduce swelling, and exercise will also help you to maintain that health. But the key thing, like I've mentioned there, synovial joints, freely movable joints, very, very important in terms of performance in sports. Again, there are 3 links there that I've given on YouTube, so you can be able to go and look at that in more detail. Muscular system, very important system. This is where now we have the effort. A lot of times we assume a lot, but the structure of the muscle is quite complex in terms of just how it is structured to be able to shorten and relax when it is providing effort for that movement. Now, there are 3 different types of muscles there: skeletal muscle, smooth muscle, cardiac muscle. I've indicated there the differences, but what you need to note, skeletal muscles are voluntary. They're under our control. Smooth muscle are not under our control, involuntary. The digestive system, you cannot control it. Your stomach, you cannot control it, right? And other systems that are there in the body, the arteries and all that. But the cardiac muscle, structurally, it combines the features of a skeletal muscle. Functionally, it has features of the smooth muscle. So it combines features of both smooth and skeletal muscle. When we go now to the structure of the muscles, and you will see this in the video, or rather the YouTube, but the myofibril is that single unit of the muscle, the contractile portion. And you'll find that within that myofibril, there is something called a sarcomere. Now, I do not want to go through all this structural stuff, because you can be able to read later and just look at that. But the key thing that I want to bring to your attention is that in the muscle, those striations that you see in the voluntary muscle, there is a dark band and there is a lighter band. That dark band is normally called the I band. Then that lighter one, the darker one is called the A band, and the lighter one is called the I band. Now, this muscle contains, I will bring your attention to two proteins in terms of the mechanisms of muscle contraction. There are actually three proteins. There are two, which is the actin and the myosin. But the actin contains two other proteins called tropomyosin and troponin. Now, these are the proteins that form the fundamentals of the mechanism of muscular contraction. It is something that is very interesting, and you can be able to go and read more of that. And it is the mechanism of muscular contraction is based on the theory called sliding filament theory. I will not go into that, but that theory is what explains the contribution of the actin, myosin, tropomyosin, and troponin in muscular contraction. It's a very interesting phenomenon, and if you just go and Google the sliding filament theory, you'll be able to see. It is a theory that has not really been proven as such, but it is the best explanation when you want to know, or when you want to look at the mechanism behind muscular contraction. What I want to bring out here as in conclusion is that muscles operate in four different groups. We've got the prime movers, we've got the antagonists, we've got the synergists, and we've got the fixators. In this table, I have itemized the function, and I've also given example when you're riding a bike. When you're riding a bike, the agonists, the prime movers, the ones which are causing that movement, is basically your quadriceps and the calf muscles. Those are the agonists. The antagonists that act in opposition to that movement for stability are the hamstrings and the shin muscles. Then the synergists assist in performing that motion to neutralize unnecessary motion. That is the other leg muscles. And then the fixators assist in holding the rest of the body in place as the movement occurs. And that is the abdominal and the back muscles when you're riding a bike. This is just an example to show you a group activity, how the muscles operate in just one particular type of movement. And there are various movements that we have in sports, and there are 1,000,001 muscles that operate in groups and bring out that quality of movement that you want. You want that movement to be controlled. So you must have an agonist, you must have an antagonist. You want stability. So you must have a synergist and you must have a fixator. It's again another very interesting phenomenon in the way the muscles operate. So muscles are very key because contraction is what produces movement. So I've itemized there short-term effects that come in terms of the blood flow, in terms of muscle fatigue. Then when we come to muscle exhaustion, muscle damage, cramps, again, very, and these are areas that I believe if you are a practitioner or a coach, it is very, very important, especially for the conditioning coaches, to be able to understand the impact of training on a short-term basis and also on a long-term basis. And that is how the muscle is probably going to react. Muscle size, we call it hypertrophy, long-term effects. And the reason why we normally do muscle hypertrophy during the off-season is because of the long-term effect. You cannot go during in-season and expect to work on muscle size because it is a long-term effect. Also, muscle coordination, also aspects of blood supply. And I've also given you 3 links there on YouTube, and I tell you, very, very interesting. If you go and watch and there is one that I believe explains that mechanism of muscular contraction. So that is something that I would advise that you go and watch when you get to the presentation. Nervous system. We've now looked at that machine, the liver. We've looked at the rigid bar, the skeletal. We've looked at the articular, the fulcrum. We have looked at the effort, the muscular system. Now we are looking at the messenger, the one that now from the brain tells that muscle either contract or relax. So the nervous system is just a messenger system which deals with the stimulation of the nerves, and it always starts. Everything starts from the brain, and the brain now sends a message to the effectors, the muscles, that do this, contract or relax. Okay, so the nervous system is a support system, and the general structure, again, I've given it there. We are looking at what we call a neuron, that is the unit, and there are basically 4 parts of the neuron that I have itemized there. And again, when you watch the video or the YouTube, you'll be able to look at all this. But the key thing, there is a cell body, and of course, the cell body is just like any other cell that you have in the human body. But the key thing here is you've got the dendrites and you've got the axons. Please note that dendrites are the ones that now take the message from the receptors at the skin. The receptors are located around the skin. These are the ones that take the message to the brain. Then the brain now gives instruction through the axon to the effector that do this and do this. And then you will find at the axon terminal, you've got neurotransmitters, because the axon terminal is the one that now joins with a muscle to form what we call a neuromuscular joint, or you have a neuron with a neuron to form a synapse. I think I've explained that somewhere on the presentation. I've explained that those junctions later in the presentation. And what you need to note here again is afferent neurons and efferent neurons. Convey information from tissues and organs to the central nervous system, those are afferent neurons. Taking messages from the central nervous system to the effector cells, those are efferent neurons. And their structure is different. I've talked about a synapse, which is a specialized junction between 2 neurons, where one neuron alters the activity of the other. But where now a cell, well, I've explained there also about neurotransmitters. A neurotransmitter is that 2 junctions do not connect directly. A neuron and another neuron do not connect directly. There's a space. That space is what we are calling the synapse. We have 2 transmitters, acetylcholine and noradrenaline. I think acetylcholine is mainly between neuron to neuron. Noradrenaline is between neuron to muscle, or vice versa. It's something like that. But it's important for you to know about those 2 neurotransmitters. They are chemicals that now transmit messages across either the synapse or the neuromuscular junction. And I think I've explained, I've also explained there about the neuromuscular junction, very, very important junction, where now the neuron connects with the muscle through that junction. And there is a neurotransmitter that is transmitting the messages across, so that the impulse travels across that space to give the muscle that message from the brain. Again, CNS, it's important to know we have 2 divisions. We have the central nervous system and we have the PNS, peripheral nervous system. Central nervous system, we have the conscious brain, and the unconscious brain. In the unconscious brain, I want to itemize the medulla oblongata. I believe that is a very common, I don't know whether to call it an organ or whatever in the body. And just note that it is the one that contains centers for regulating heartbeat, breathing, and all that. And then we've got the other one called the hypothalamus. That is more, it deals more with internal environment and aspects like hunger, sleep, thirst, body temperature, and all that. We also have the thalamus. We have the cerebellum. You can read about that when you get to the presentation. Also, when you watch the YouTube. Now, the spinal cord now mainly contains now the peripheral nervous system. I've just explained a bit more of what is in the spinal cord there. But we are now looking at the peripheral nervous system. We have the CNS, which is mainly the brain, the spinal cord, and then we have now the nerve fibers forming the peripheral nervous system. There are 12 pairs, there are 43 pairs of nerves, 12 pairs of cranial nerves, which serve the head, neck, facial regions, and then you've got the 31 pairs of spinal nerves, 8 in the cervical region, 12 in the thoracic, 5. So you can see this mainly depicts the way the vertebral bones are divided in the spinal cord, the vertebral bones. I've talked about afferent again, but what I want to bring out here is that the peripheral nervous system is divided further into what we call a somatic division and autonomic division. Somatic division is the one that innervates the skeletal muscle. That is very key for sports. Autonomic division innervates all the other tissues other than the skeletal muscle. And if you come to the autonomic division, again, you will find, and this again is very interesting, you now have the sympathetic and parasympathetic division. I have highlighted there the second part there because to me, this is where the relevance of sports comes in. Fight or flight. You know, there are times, for example, there are times when you are faced in a situation where you either fight or you run, and sometimes you wonder, where did I get the energy from? Or how did I do that? That is what the sympathetic division is helping out. It prepares you for emergencies. The parasympathetic division just deals with a normal activity that is not under your conscious control. Digestion of food, contraction of the pupils in the eye, and all that. So that's just a way of showing you how the autonomic part of the nervous system operates. Again, you can do a lot more reading on that if it's generating some interest for you. Application, like I've said, the central nervous system is a messenger. It is it's a very, very important system in that it's now the one that is controlling all these movements that we are talking about. And it monitors and controls the muscular action so that you're able to have harmonic and effective movement in the body. Again, there are 2 links there on YouTube for you to go and watch, be able to get that. Now, I do not want to say that this is the most important system in the body because all the systems are important. But the cardiovascular system is key for us in our sport because that is the system that is responsible for transferring or for transporting the raw materials that are required for manufacture of energy in the body. And that's why I'm saying it is fundamental. Let's not use it's a fundamental system. And it is a system that really, in our sporting setup, you want to ensure that this system adapts so that the body becomes more efficient. So it is a system which transports oxygen, mainly from the atmosphere to the body tissues, so that this oxygen can participate in the manufacture of energy, as we'll see later when we go on with this presentation. Now, when we look at the cardiovascular system, the heart, a very small organ, but a very important organ. Internally, the heart has a right and a left side. It has 4 chambers, 2 upper chambers, the atria, and 2 lower chambers called the ventricles. Now, it is again very interesting the way the heart operates. It's a double pump. It's a pump, actually, the largest pump in the body. It's just a pump. And it operates in a twofold way. Blood needs to be pumped from the heart to the body. So that is from the left ventricle back to the heart. Then you have from the heart to the lungs, through the right ventricle and back to the lungs. So you have 2 circulations that are taking place. And again, very, very interesting. And those 2 circulations, the first one is called a pulmonary circulation. And that is the one that now takes the blood. It takes the deoxygenated blood into the lungs for purification, and then you have the systemic circulation that now pumps the blood to the rest of the body. So, interestingly enough, the right side of the heart pumps blood to the lungs. The left side of the heart pumps blood to the tissues. Okay, yeah. So those are the 2 circulations that we are talking about, and that's why the heart is referred to as a double pump. Now, the heartbeat, very important. The atria contract simultaneously, then the 2 ventricles also contract simultaneously. That's how the heartbeat happens. So you have a systole, a contraction of the heart muscle. You have a diastole, relaxation of the heart muscle. I just want to, and it's very interesting there, the heart contracts or beats about 70 times a minute. We talk of 72. And the heartbeat lasts about 0.85 seconds, one heartbeat. And I just wanted to show you something very interesting there. There is the atria. When the atria are in systole and the ventricles are relaxed, that is 0.15 seconds. Then when the atria relax and the ventricles contract, 0.13 seconds. And then there's a situation where both the atria and the ventricles are relaxed, and that takes about 0.4 seconds. It's a very interesting phenomenon, the way this heart operates. And during this time, the 2 circulations are happening at the same time. Yeah, the pulmonary circulation is happening, and the systemic circulation is happening at the same time. Not that one takes place and then the other comes later. The cardiac cycle. Remember, cardiac output is the volume of blood leaving each ventricle in 1 minute. That's the total. Heart rate is the number of times the heart beats in 1 minute. Stroke volume is the amount of blood injected from a ventricle per beat. So, heart rate times stroke volume gives you cardiac output. Now, I want to give you a hypothetical analogy here, which I've not put in the slide. Take an example of a cardiac output of 18. Now, you can get 18 in 6 ways if you look at heart rate and stroke volume. You can get 1 times 18, that is a heart rate of 1 and a stroke volume of 18. You can get 2 times 9, a heart rate of 2 and a stroke volume of 9. You can get 3 times 6, heart rate of 3, stroke volume of 6, and then you can go to 6 times 3, heart rate of 6, and whatever. Then you go to 9 times 2, heart rate of 9, stroke volume of 2, and finally 18 times 1, heart rate of 18, and a stroke volume of 1. Now remember, the heart uses energy. So I would not want a heart that is beating at 18 beats per minute and only producing 1 volume of blood is not the kind of heart that you are looking for. You are looking for a heart that is going to beat probably with 1 beat and give you 18 cc's of blood, or 2 beats and give you 9 cc's of blood. So in sports, what we expect, the adaptation, is that an efficient heart will beat at probably 60 to 65 beats per minute. There's some athletes, these endurance athletes, could even be, the normal heart rate could be even 55 per minute. That is an efficient heart. But if you have a heart beating at 98 beats per minute and producing very little volume, then that is a bit of a problem. So that is how you manipulate and in sports and get the heart to be efficient through training. So remember just remember that formula, that heart rate times stroke volume gives you cardiac output. I've itemized now the vascular system because the heart now pumps, and the vascular system is responsible for now transport. Just remember, the arteries operate on elasticity. And that is why as you grow older, the elasticity tends to degenerate. And that is what creates things like high blood pressure and stuff like that. But it is a contractile thing. So it is that pressure system that is developed because the arteries divide into smaller units called arterioles that are smaller when they move now from the heart to the body. So there's a pressure system that is created that transports the oxygen through the arteries. And of course, you have the veins that carry the blood now from the tissues back now to the heart. The oxygenated blood is coming back to the heart again for purification. Then, of course, you have the capillaries that serve as the bed for diffusion, the exchange, the gaseous exchange, which again I will highlight where they take place. So again, I've just mentioned there I've just come back to now explain more about the pulmonary circuit and the systemic circuit. Okay, the 2 circuits that we have. I think I don't want to ever emphasize, but in terms of application, this is the fundamental system that we need to work on for efficiency. And this is the system especially for endurance athletes that really needs to be trained. And it's the most important adaptation that you would have to work on to bring about efficiency. I've given a very detailed, there are 2 links there that you can go through and get now the explanation better about this system. Now, respiratory system, breathing. This is the system that is responsible for bringing in the oxygen. I just want to bring out the 2 areas of exchange. When we talk about external respiration, this is where the exchange takes place at the lungs. Internal respiration is the exchange that is taking place now at the tissues. Remember, at the lungs, we want oxygen to come in, we want carbon dioxide to get out. At the tissues, we want the oxygen to go in into the cells, we want the carbon dioxide to get out so that it goes back to the lungs and is ejected out of the body. Now, breathing, again, the way air is conducted in, there's a whole system there that are itemized, and you can see them through, again, the link I'm going to give. But we have the nose that is the one that is responsible for now bringing in the air. You've got the pharynx, that is just an organ that separates. Remember, this nose goes and links up with the esophagus. So you must separate the air and the food channels. And that's basically the function of this. The larynx is more of a voice box, but there is that aspect of the glottis, which really translates into the epiglottis, and that is what separates the food from the air. Trachea, bronchi are just organs that lead us to the lungs for that exchange to take place, the external respiration. The mechanism of breathing, very interesting again. The key thing that you need to note here is that it is the concentration of carbon 4 oxide in the blood that stimulates, that goes to the brain to tell the brain, now get the mechanism of breathing working. It is not the amount of oxygen that you have in the blood. It is the amount of carbon 4 oxide that you have that now stimulates the breathing center. And now this is where you have the diaphragm, and you have those intercostal and intercostal muscles at the ribs. Okay, so you have that contraction of the diaphragm, and I don't know whether it's the external intercostals that are responsible for ejecting the air out, and then you have the relaxation, and I think the internal intercostals that reduce or increase the size of the cavity so that the air can come in. What again I want to point out here is inspiration is the active phase of breathing. Active in that it requires energy. It requires energy for those muscles to be able to contract and get the chest cavity bigger for the air to come in. So it's an active phase. But expiration, expelling the air, is not an active phase. It just happens because now elasticity of the diaphragm and those intercostals, they relax, they now relax, and they go back to their original positions. And because of the elasticity, then the air is ejected out of the system. Again, very interesting phenomena when we come to the to mechanism of breathing. I've already mentioned about external respiration. It's the exchange of gases between the air in the alveoli and the blood within the pulmonary capillaries. This takes place at the lungs, and the mechanism is diffusion, right? Where you have a higher concentration of a gas moving to a lower concentration. Then again, what you need to note is that internal respiration takes place now at the tissues, again by diffusion. So two gaseous exchange sites are in the body, the lungs and at the tissues. Again, I've just given you a table there, comparison of gases in the atmosphere. I think this is actually common knowledge. Oxygen, atmospheric air, we have about 20%, 21%. Nitrogen, we don't use nitrogen, so the percentage stays the same. Carbon 4 oxide, you can see, is very little in the atmospheric air, but the expired air, there is 4.1 there. So that's just a table that I was giving for comparison of the atmosphere and the expired air. Again, respiratory rate usually determines the amount of oxygen that is delivered to the muscles during exercise, and that is critical. The larger the lung capacity is, the more air, specifically oxygen, can be taken in. And this lung capacity can be increased through training. So again, that is an adaptation that is important. And regardless of whatever type of activity, athletes will normally have a higher lung capacity than non-athletes because they use their lungs a bit more. So you will always have an increased oxygen intake, allowing those lungs to go in strength. And I've also given a link there for further study. And we now come to the last chapter. Again, fundamental energy production. Remember, we eat foods, simple sugars, carbohydrates. We eat protein, which get to be broken down to amino acids. We eat fats that get down to fatty acids. And then we need now that metabolism where you see the body cannot utilize these food chemicals the way they are. It needs to be broken down. And this is where oxygen comes in, because you need to break down the carbs into simple sugars. Then there's this, of course, I've explained about a calorie there, a conventional unit for energy. But what I want to bring out here is this complex molecule called adenosine triphosphate. And then we also have creatine phosphate. This is the way that the body will now consume that energy. So the carbs and the fatty acids and even protein to an extent will always have to be broken down to manufacture this ATP. I will not take you through. It's a very complex system that can, but it's something that you can read about in terms of just the way energy is manufactured. But I've given just a brief analogy there. This molecule called ATP was first isolated in the early 1930s by a gentleman called Lohmann, and it is just a nucleotide that consists of complex organic molecules, adenosine, and then you have 3 phosphate groups that are attached. And the whole system of the manufacture is just a simple sugar is hydrolyzed in the presence of an appropriate enzyme, and then ATPs are manufactured. There is something called the hydrogen carrier system, or you'll find some books refer to it as oxidative phosphorylation, or you will find some books referring to it as the electron transport system. Very interesting. I would encourage you to go and read about it, but we just have carriers. We've got what is called NAD. You don't have to remember that long name. We normally just talk about NAD or FAD or cytochrome, and the fourth carrier is a cytochrome oxidase. It's an enzyme. So you will find that through this hydrogen carrier system, when NAD is used, you'll find 3 ATPs are manufactured. When FAD is used, the system starts from FAD, then 2 ATPs are manufactured. Very interesting. I would encourage you to go and read about this just to understand how it works. But that is the basic process of the manufacture of ATP, the hydrogen carrier system. Glycolysis is the first process in manufacture of energy. It was discovered by those 2 German scientists. But the key thing is that the end product of glycolysis is pyruvic acid. Now, that pyruvic acid, if oxygen is available, can proceed in 2 directions. If oxygen is available, it enters what is called the Krebs cycle. If oxygen is not available, that pyruvic acid goes into lactate or lactic acid. And sometimes that is what causes a muscle pull. When you go and you exercise without warming up, and suddenly oxygen is not available, but the energy producing system has started, and you will find that now pyruvic acid is being converted into lactic acid because of that unavailability of oxygen. And sometimes you have to stop and recover. Now that is when now the oxygen comes in, and then it will enter into what we call the Krebs cycle. Again, very, very interesting phenomenon, which I would encourage you to read about. I've not gone into great details here about the Krebs cycle. It is something that you can go and read, and you can even watch the link that I have indicated there. But it is called the Krebs cycle because it was discovered by Sir Hans Krebs, and sometimes it's also referred to as the citric acid cycle. Okay, but it is the cycle, it is the process that produces the most ATPs. And one glucose molecule, if it goes through glycolysis and the Krebs cycle, will give you 38 ATPs. A maximum of 38 ATPs are produced by the complete oxidation of one molecule of a 6-carbon sugar. What you need to note here again, glycolysis takes place in the cytoplasm of the cell, while citric acid cycle or Krebs cycle takes place in the mitochondria. Mitochondria is the organelle where now this tissue respiration takes place. Now, within that mitochondria, you will now find that oxidative ATP PC system, anaerobic glycolytic system, aerobic system. The systems are just, they work together. But you will find that now what is called the phosphagen system is more geared towards the sprints. It's a situation where your body has not yet gotten the oxygen in. For example, if you're running 100 meters, I believe they even hold their breath. You can hold your breath for that 9.8 or 10 seconds that you're running. So there is no oxygen coming in, but there is normally readily available ATP in the form of what is called creatine phosphate. And that's why sometimes it's called the CP system. So that is the one that provides the phosphate that is required for that, for that energy. But it is not enough. So you can run the 100 meters or you can do the 200 meters, but you will still need now the glycolytic system that now is anaerobic. So we start off with the phosphagen system, then we now go to the anaerobic glycolysis system. This is where now the process of glycolysis is taking place. And a lot of pyruvic acid now is being produced during this time. If you analyze 100 meters running, probably the phosphagen system is dominant. Maybe from 800, from 400 to 800, you could have the anaerobic glycolysis system also coming in to be dominant now. Then when we go to endurance, then we have the aerobic system coming in, which is now when the oxygen is fully available. What I want to bring out here is that the three systems operate concurrently. It is only that for a particular activity, one system could be dominant, the other one not dominant. But now you can see that even the marathon, people are even training the phosphagen system for the finish. If you look at even the way the 10,000 meters is being finished now, that last 400 meters is almost like a sprint. So that means that you have also worked on the phosphagen system and not just the aerobic system. Again, a very interesting analogy here that you will need to read. So what I'm saying there is whatever sport that there is, aerobic energy provides the base for fitness, regardless of which specific energy system demands of that actual sport. But the three systems operate concurrently. And you need to see, how do I train the aerobic system? How do I train the anaerobic glycolytic system? And how do I train the phosphagen system to be able now to achieve that performance that you want in that particular activity. And again, I've given, there is about 5 links or 6 links there that you can be able to go to and be able to get this aspect clearly. And I think with that, thank you very much for listening to me, and God bless you. And I think, John, I've used my time pretty well. Thank you very much.
Thank you, Dr. Tang, for such an elaborate and wonderful presentation. I believe all of us learned 1 or 2 in terms of physiology, anatomy in terms of the various sports that we are involved in. So maybe I'll just invite questions or comments or clarifications from any of the participants. The floor is open for anyone who has a concern.
Well,
Mr.
shall I stop sharing, John, so that I can see people?
Yeah, you can.
Okay.
Anyone with a question or a concern? Anyone who needs any clarification? Oh, there's Lillian.
Good evening, and thank you, Dr. for the presentation. Mine goes to those who have stopped participating in sports actively, and they have been encouraged to still continue to train. So when these athletes are moving away from active training, is it like they would require to have some first kind of reduction in the extent to which they train on, or how would you advise, Dr.?
Yeah, it is. You see, this scientific knowledge is very, very important, and I don't know how we can be able to incorporate this within their training so that you don't completely stop exercising and all that. So for me, I believe it's a question of just education and encouraging people to be more of get more of the scientific knowledge in terms of anatomy, physiology, and biomechanics, and up to physiology of exercise. So it's a question of just educating and emphasizing more on the scientific principles so that people really understand why I need to continue training. And if I stop training, this is what is likely to happen. So I think more of what we are doing for me is really the way to go.
Thank you so much for a wonderful presentation. I agree with you completely on how important it is for coaches to have a better understanding of the scientific principles behind sport. Can help them so much in developing training plans for their athletes, make them better coaches. Thank you so much.
Thank you. Please just ensure that you go through those links when you get my presentation. Please go through the links chapter by chapter, and you will get more, more of the illustration of what I've talked about. I was not able to show diagrams during the presentation.
Ochieng, you are on mute.
Hello, Doc.
Yes.
Hello. Yes.
Mine Ochieng, I just wanted to know, is there a situation whereby a coach can emphasize on one energy more, and then it affects the other? For instance, I'm talking of basketball. If the coach trains more of aerobic, is it going to affect the team during the match day?
You see, like what I'm saying. In fact, I think basketball has become so fast. I'm just
Yeah,
trying to think of when I used to watch the basketball in the 1980s, and what I'm seeing of basketball right now.
yeah. It's totally different. Totally different. Yeah, it's pretty fast.
Yeah, and and it's not just basketball. Even if you look at hockey,
Yeah,
if
because
yeah, it has changed because of now the emphasis on these other energy systems that people never used to emphasize on.
yeah.
To answer your question, the coach
Mhm.
should be able to see how do I train this particular system and what is the way to do it, and how do I also train this particular system. You've got to train the phosphagen system because of the intensity that I'm seeing now in most of the sports. So it's
Yeah,
the
because
question of when the coach is drawing his training plan.
yeah.
Yeah. You see, like when you're training the kind of cardiovascular system, you can use the long, slow endurance training, you can use interval training,
Yeah,
you can
yes.
use circuit training, you can use plyometrics, which brings in more of power and intensity and all that. So I think it is for the coach to understand and to know how am I going to draw my training program so that I can be able to train all these three systems that I require, and how much do I give in depending on the intensity that you want your players to play in a particular game.
Yeah, coach, and that is why I agree with you totally, because I fail to understand where you find it's almost end of the season. People are going into into the final four. That
Yeah.
is the playoffs, and you find maybe coaches deciding that they are going for mountain run. So what is your take on this?
Yeah, you have very interesting. I'm laughing because I'm just reminding myself of some coaches who in soccer who normally complain that, oh, the boys are not responding to training, and then when
Yeah.
you go and look at his training session, he's actually coaching the wrong energy system for that particular game.
And that's what amuses me, coach, and that's why I was asking you the same,
Yeah.
because at the end of the day, it is just like playoffs is like it's at the peak,
Yes.
almost ending the season, and here you're going into endurance. So, and that's what I was saying, in this kind of training, is it not going to affect the players? That is injury now comes in instead, and so many other factors maybe.
Yeah, but take note also
Yeah.
that apart from just the energy systems, you need to have something also called periodization.
Yes, correct. Yeah.
Yes, where you are looking at volumes and you are looking at
Correct.
when do you want the players to peak.
Correct.
You see,
Correct.
yeah. So a training plan is something that is so technical that you really need to look at that, because if you are approaching those playoffs, for me that is where the peak should be. So how have you also administered the volumes as you are
Yes.
approaching these playoffs? You see,
Right.
as you are doing your plan. So a lot of other factors also coming. You see,
Okay,
but
and then
yeah,
okay, sorry, and then finally,
yeah.
could you just maybe explain to us where coaches talk about? I've heard this word so much about loading.
Yeah, that's why I'm saying loading is just the volumes of training.
Right,
You
yeah.
see, yeah, but there are times when you are approaching the peak and you might even just want to give the players time to recover because you have overloaded. You see, but some coaches go loading, thinking that now this is what I need to do, when actually the players just need recovery as you
Sure.
approach the playoffs. You see,
Thanks, coach. Right.
yeah. So it's really a technical thing in terms of what do you want to achieve, what type of players do you have, what have you been doing during the preseason, in season, as you approach the time when you want the players to peak. And this is why sometimes you find players have peaked at the wrong time, and by the time you are approaching the playoffs and the final, they're already out of it.
Right.
You see, yeah. So it's a question of the energy systems and the volumes and what have they been doing during the in season, as you approach this time when you want them to peak.
Thanks, Coach.
Periodization. So it is
Right.
something that coaches need to sit down and really look at.
Sure. Agreed. Agreed, Doc.
Doc, we have two questions. One is on the
Yeah.
chat box, asking about
Sorry,
capillary bed, and then there's one hand up, Limbani Yatani. So I don't know which one. Let's go with the one which is on the chat box, and then we can have Limbani come in.
Now let me see. Oh, the chat box. I was not even looking at it. Now, you're talking about perfusion. On the capillary beds, you're mainly talking about diffusion. I don't know where does perfusion come in terms of the process that is happening, because it's an exchange that is happening at the capillary beds where we have the external respiration taking place. So I don't know, I don't really understand the question in terms of where does perfusion now come in. I don't know, maybe you can explain further.
Harrison, it's from Harrison, probably you could clarify exactly what you wanted to ask.
Yeah. Because the key thing at the capillary beds is the exchange.
Harrison, are you with us? Okay, maybe he will join. We can have Limbani Yatina.
Okay, thank you. Thanks so much for this great presentation, which is insightful. Okay, so for me, just wanted to check something to find out, because I see this as a very important area or subject. But then I also appreciate that it seems to be too scientific at one end. So I wanted to know to what extent or how deep should a coach go in this subject to actually be at the comfortable level of applying this to help athletes or a team. Also keeping in mind that perhaps on the other side, I was thinking that maybe a structure of a technical plan will also have some sort of physicians and all that kind of personnel. Is it mainly on the responsibility of physicians to go more deep in this area, and then you just do some sort of a collaboration with the coach? Just wanted to find out that balance and understanding. Thank you.
Yeah. What you have asked, in fact, actually, when I discussed with John about coming to do the presentation, I wanted, because I didn't even know the clientele, so I decided to try and be as basic as possible, and that's why I didn't go so much into the details of some of those processes. You can look at them in the YouTube. But to answer your question, depending on the level of your coaches, I think you need, first of all, to profile your coaches to understand what is their background, where have they come from, and then the introduction of sports science in terms of things like anatomy and physiology should be done as basic as possible. You know, it is scary when somebody sees some of the terminologies that you have, and he's probably been coaching without really knowing. Sometimes he doesn't even know the name of the muscle that he has been coaching and all that. So we also don't want to scare people. You don't want to come in and scare somebody and somebody thinks, wow, I've even been doing the wrong thing. So you must profile what is the background of your coaches. And then once you get the background in terms of, a lot of people don't have this scientific background. And then you see what is the best way of introducing these principles as basically as possible. So my only answer to that question is you need, first of all, to profile. What is their background? What is the academic background? Are they endowed with this scientific knowledge, or they don't have it? And then you see how gradually you can introduce you don't want to scare people also by coming with all these scientific terminologies. You've got to see how to break it down as simply as possible. I don't know if I've answered your question.
Yeah, that's fine, because I think my main
Yeah.
area that I want to know is how did
Yeah.
someone has to go. Yeah.
We don't want to scare. We don't want to scare by somebody saying no. Or I don't have that that background and I can't. We want to see how can they get this knowledge, and you synthesize that knowledge so that they're able to understand slowly, and then you progressively see how you can increase the depth of what they're being given. It can be scary.
Can I add something on that,
Thank you.
Dr.
Yeah, John, please.
Yes, and that is the main objective of this forum, so that we can introduce the science aspect of coaching to all our coaches. Because what you realize is that most of the coaches do not have that scientific background in terms of their coaching. Most of the coaches just became coaches because they played the sport, and through that they learned, they saw what was being done, and they're doing it without really understanding the reasons or the logic behind whatever is being done. So slowly by slowly, like we start on basics, you've provided links. If people follow into those links, they'll be able to understand and practically be in a position where practically they can use that knowledge in terms of coaching or talking to coaches and athletes. Thank you.
Thank you.
Yeah, there's somebody who wants to talk. All right. If there is no any more concern, then probably would have to bring this meeting to an end. And before I do that, just to appreciate those who found time to attend and the knowledge or the experiences that you've shared across. Otherwise, Mr. Tank, thank you again. And we hope to have you in the near future. You talked about training plan. Probably you could prepare a presentation on that and share with the coaches here if time allows. Otherwise, thank you so
No
much.
problem, John.
And
No problem.
yeah, and if you have anything to say to the group, you can kindly go ahead, and then we bring this meeting to a close.
No. Thank you. Thank you very, very much. And I really appreciate this kind of forum. And I appreciate the kind of exchange we've had. If we had a bit more of time, I know we could have gone into a lot of discussion. But thank you so much. And I'm promising that whatever we can be able to share, like John has talked about, training plan, that's another technical area. We can find time and discuss that later. So, John, I will send you the presentation, and you can either put it on the site or see how people can be able to get the presentation. But thank you so much, and I appreciate it.
Welcome, Dr. and we also appreciate. So as I'd indicated in the chat, if you didn't get a direct invite, you can share your number so that you can share this presentation on the WhatsApp line. But if you do not, we'll still post it on our website where you can access it and other materials that are there. Otherwise, thank you guys and have a good evening.
Thank you. Good night.
Then there's a link that was shared for review. If you
Thank you very much.
If you can give us a review on what areas that you feel we need to improve on, or whatever we are doing well that we need to keep on doing well. Thank you guys and have a good evening. The link, you can click on the link, it has been shared, so that even if I end the meeting, you are still able to access. All right, guys, have a good evening and see you next time.